Hello, in this video we're going to go over a couple of examples of circuits using decoders. The first example is to design a 3 to 8 decoder using 2 to 4 decoders. So first we're going to use only 2 to 4 decoders, and you have to think about how the 2 to 4 decoder works. So depending on the values of the inputs, depending on the value of the input to the decoder, that's the output that is going to be high, or the output that is going to be on or active. So in the case of the 2 to 4, we need to select two inputs. In this case, we can have the W1 and the W0. And depending on that, it's going to be turning on either Y0, Y1, Y2, or 3, right? That's one possible option. And then the other one is that it depends on the W1 and W0. It could turn on Y4, 5, 6, 7, right? But now we need to maybe use some other logic gate, some other decoder to activate whether the top part of the truth table is active or whether the bottom part of the truth table is active. So just think about how this can be done. So if we use 2 to 4 decoders, we're going to have 1, 2, 3, 4, and then we're going to have another one, 1, 2. Of course, we have the enable. And so in this case, we can select, we can have another 1, 2, 3, 4, of course, with an enable. Okay, and so if we were to put W0, W1 here, and that means that that's a 0, 1, 2, or 3, depending on the values of the W0, W1. And so we can have the same here, W0, W1, 0, 1, 2, and 3. And so depending on that, which one it's going to be turned on, the top one or the bottom one, right? So that's going to correspond to the top of the truth table, the bottom of the truth table, and then we can control with another decoder, we can control which one is on. So if I were to put a W2 here and a 0, so remember we're putting the most significant bit here, most significant bit, most significant bit, okay? And so we don't have all of the values of 0, 0, 0, 1, 1, 0, 1, 1. We only have a 0 and a 1 for W2. So that means that we're going to be based it off of this, right? So 0, 1, 0, 0, that would be this one. That would make this one turn on, the top of the table. And then if we have a 0, 1, that means that W2 is a 1, then that's going to turn on this bottom decoder. So now we can say that this is Y0, 1, Y2, Y3, Y4, Y5, Y6, and Y7. Okay, and then of course the enable is just going to depend on our enable signal if we had one. And that's because we only have how many rows? We had 8 rows. So 8 rows, we don't have more. Another case that we can do is we can also use decoders and other gates. So the right hand side is going to be the same. The right hand side is going to be the same, but now we need to design logic circuit that is going to turn on either the top one or the bottom one. So remember the top one, top it's on when W2 is equal to 0 and where enable is equal to 1. So that's AND, right? So that means W2 not enable, regular enable, right? What about the bottom one? The bottom one is on when W2 is equal to 1 and enable is equal to 1 also. So in that case, we can have like this. Remember, it's an AND, so we're ANDing W2 and enable, right? So you can kind of think of it in words and then translate that to a logic circuit. So in the case of the bottom one, we need an AND also. Remember, this is an AND. And we have W2 coming from here. And we have enable also. So if W2 is 0, then that's going to turn on this top one, the top one. And W2 is a 1, it's going to turn on this one. So what about we have an example where we design a 4 to 16 decoder using the 2 to 4 decoders. It's going to be similar to the previous one. Now in this case, we don't have 8 rows, we have 16 rows, right? So we have 16 from 0 to 15, that means 16 rows. Right, correct. So how many 2 to 4s I'm gonna have on my right hand side if I have 16 rows, 16 outputs? So 16 divided by 4, right? Divided by the 4, so it's gonna have 4, right? So we're gonna have 4. Then each of them is gonna be controlled by what? So that each of these is gonna be controlled on another decoder. So we need to be able to differentiate between this part, the blue, the green, and the yellow, right? So how to differentiate that? With these two values. So look at this, we have a 0, 0, we have a 0, 1, we have a 1, 0, and we have a 1, 1, okay? So let's look at the diagram. So we set 4 of these here. And remember, we have 1, 2, 3, 4, 1, 2, 3, 4, y0, y1, 2, 4, y5, 6, 7, y8, 9, 10, 11, y12, 13, 14, 15, y15. Okay, then we're going to have the two values and an enable, two values enable, two values enable. This is our enable. And remember how do we turn on each of these? With the enable, right? So remember our table, we had W3, W2, W1, W0. So W0, W1, they're all going to be connected here. All my, let me see, all the W0s are going to be connected to this W0. That's W0, and then W1, and then these enables going to be controlled by what? Another one. 1, 2, 3, and 4. So it's like the 4 divisions of the previous table, right? And that's going to depend on what? W3 and W2. Okay, remember the most significant bit goes here. And of course, we have an enable. And so depending on what these values are, it's going to be looking at the top, the second one, the third, and the fourth section of the table. So that's it. That's how you kind of can design bigger decoders. when you only have smaller decoders.